Just cut it.
Woohoo! Thank you, Mark, for the intro. I'm super happy to be here. I'm Phil. I'm a PM at Lyft in the data discovery team.
Hi, I'm Jin, a software engineer in Lyft.
So we're here tonight to talk about how to disrupt data discovery. And we're going to start by giving a quick intro about the data at Lyft. Then we're going to explain what are the main challenges of data discovery and how we are solving this by building a tool called Amundsen. Then we're going to dig deeper into how Amundsen is built and explaining its main architecture points. So Lyft is mainly mobile-based. We all use the mobile app. And the mobile app fires events into Kafka Kinesis a bus. And we also have, according to the bus, events from the servers. So through some ETLs, this comes into the Amazon S3, that is our layer for storing data. So it used to be pretty simple. It used to be only Amazon Redshift. Now it's way more complex. On the high level, it's we use Hive, Presto, and Druid. So Hive for more longer run ETLs, and Presto for more like quick analysis. On top of this, we use different tools. So these tools are Mode, Superset to do some visual analysis and some SQL queries. We also use Tableau and Looker, and different set of various apps. So at Lyft, we really want to make data the heart of every decision we make, because we want to make the right decisions. And so anybody whose job is to make decision at Lyft is going to make it based on data. So either you're a data scientist, a product manager, maybe you are the general manager and responsible for the New York City region, maybe you're an engineer. Anyway, whenever you want to make a decision, you have to make it based on data. So the different steps to make a decision based on data are these here. First, you have to search and find data. Then you have to understand the data that you just found. And this is where you do the heavy lifting. You perform an analysis or some viz. This is like what you're actually paid to do, I guess. And finally, you can share insights or just make a decision based on your pay, based on how much you paid. So let's take the example of a junior data scientist, someone who just joined Lyft. He's super happy because he's got a first project, and he wants to predict the attendance of this meetup. And the goal is to help the office team to just gather the right number of chairs. So I guess in this situation, he didn't make a good job because some people are standing there, but we have some seats here if you want. So as I said, first step is to search and find data. So as you just joined, you don't really know where the data lives. You don't really know what tables you can access. So what you're going to do is you're going to ask your friend, ask your manager, ask your coworkers, where is the data that I could use to like compute this thing, or for the chair thing. Maybe they don't know, maybe they know, but maybe they don't know. So maybe you're going to go to the next step, which is going to go to a Slack channel where a lot of people are connected to this Slack channel. So you're going to ask a question. You're going to see that the only answer you have is people leaving the Slack channel. So you're going to go into GitHub, and you're going to search for different repos for this table that you're not finding. Maybe at the end you'll find it. So let's say you find it. It's called hosted events. and it looks like the right one. Step 2 is to understand the data. So you got this field called attendance, and it seems like it could be useful, but you don't really know actually, because maybe it's only like maybe it takes into account the employees, maybe it doesn't, but actually people from Lyft also want to sit, so you really need to know that. Plus you want to buy some pizzas, so you need to think about costs. So you really need to dig deeper into the data. And to do that, you're going to use something like mode or superset, and you're going to run queries like select star. So let's take a step back and think about how this can scale to all the employees at Lyft. So these two first parts, when we ask around at Lyft and outside of Lyft, we understood that people take 30% of the time to do these two parts. And as I said, this is a big problem because this is not some value-adding work. People at Lyft and in other companies are super skilled. They've done some amazing studies, and they want to bring some value by doing some fancy analysis, building some models. They don't want to do just finding data, right? So we wanted to focus on two main personas, the data scientist and the data analyst, because we think that these people are really like the one that should not focus on finding data and should focus on really delivering value through insights and model building. They use frequently data. They do this every day. Sometimes they do just like finding insights. Sometimes they want to build models. But really, they're exposed often to new data sets, and data discovery for them is really a pain. I think we can break them down into two different types, the noob users and the more seasoned users. And they have different pain points. So the noob user, as I said, he needs to ramp up fast because he wants to bring value fast. So the issue is that he doesn't really know where to start, so he's going to wander around, explore a lot, and he might make some mistakes. On the other side, the power user, he knows a lot. He's been at Lyft for a long time, and he knows where data is. He's got some knowledge in his head that he needs to share with a noob user, and that actually takes some time for him. And he's going to be paid a lot, so it's like valuable time. And the thing is, like, if he changes teams, maybe he's going to switch from being a power user to being a noob user, and that's very painful. So when we really take a step back and think about data discovery, there are three different types of discovering data. First thing is like the actual searching for something. So you go to a search bar and you type cancel rates or something like this. You want to understand a question like, what is this table? Where is the table that contains that data I might be interested in? Like, is there an analysis that already exists on cancel rates? Then you have another way to discover data. It's more lineage based. Let's say there's an event that is broken, and you want to know what are all the tables that are impacted by this broken event. The third one is network-based. So you know that this coworker has a lot of knowledge and uses exactly the tables you want to use. So you're going to check out what he uses. You also may want to know like what are the tables that have the most use, because that's most probably the one that you want to use too. So the moment you've been waiting for, I'm introducing Amundsen, which is this guy. He's the first person to go to the South Pole, and also the first person who went to both North and South Poles. And we thought about this name because it's going to the South Pole is kind of like finding data at some point, like super hard. So this is what it looks like. It's basically a search bar, right? We added some popular tables because you want to like maybe try it out and also quickly access some of the most used tables at Lyft. But it's a search bar, so we want to rank results. And this leads to the question, how does search work? And basically, we base our search on two things. First one is relevance. So if you're searching for an apple, you really want to have this one and not this one in the search results, right? But also, if you're searching for an apple, you want to have the most popular apple. You don't want to have a shitty apple. And to do that, we actually parse query logs, meaning that the most used tables are going to be on top. And the hard thing now is that we want to take these two sides into account to create one index in the search results. So we have to balance both. So now we're going to switch to the demo.
Okay. Thank you, Phil. Okay, so this is what you saw from the slide. This is the first page of Amundsen. In here, it's like a Google. You can type any search term that you want. For the purpose of this demo, because of the security reason, I'm gonna type the table name, which is actually produced by Amundsen itself. So when I click enter, it show you one result. It could show you like multiple results, thousands of results, and the results are sorted by relevancy and popularity. And as Phil mentioned, that the popularity is computed by how many queries that user put against, in Lyft case, Presto. It's not about how many times they're using in Amundsen on that certain table. So, and you can click this one of the result, and you can see also that it also show you when this table has been last touched. If you click one of the result, it brings you to the table detail page, brings you more metadata here. Here on the top left, it show you table schema, table name, and here's the partition availability. Basically show you how much of data available. In this table, it shows you from 2018 to 2019, there's data available. There's a table description. If you think that is incorrect, or if you think that you can enrich this table description, you can also add it. Down there, there's a columns, column name, column type. You can also add a column description. Let's see. In the column, we also provide you more metadata, such as statistics like this. We think that this is very useful for if you are going to query this table. You can immediately see that there's a distinctive value of 5, as well as there's no null value in this field. On the right side, it also show you owner, which is a network-based search that Philip just mentioned. So basically, you can contact them to ask more about the data. Down there, we also provide you the frequent users. It's top 5 frequent users we computed by parsing our SQL query. Down there, this is a lineage-based search. We provide you which application produced this table. Here in this table is produced by Airflow DAG. And this is a table lineage. We are using actually third-party vendor. They compute the table lineage in column level. So far it provides you quite many metadata, but if you still want to figure out how the data looks like, we provide you a preview function, basically give you more feeling about the data. Once you think that this is something that you want to explore more, we integrate with the superset, which is a visualization layer, so that basically it brings you to the SQL lab. You can start querying against the table. Here's the tag that you can basically add customized tag over here. It will basically bring you customized search experience. If you think that basically, for example, this belongs to a certain project, you can add that project name. And then when you search for that project name, this table will come up. Amundsen is currently not real time. So on the bottom, it shows you how latest the data is, our metadata is. So it shows that it has been indexed this morning at 6:40 a.m. And last but not least, we embedded a feature to rate this Amundsen product, rating, bug report, and feature request. This has been a really big win for us so that we can improve very fast with the user request. Okay, that's pretty much it for the demo. Thank you. Okay, so I'm going to talk about Amundsen's architecture. Could be boring, but we just open sourced Amundsen. So thank you. So for those who are interested in using it or contributing it, will be I hope it will be a helpful session. Okay, so this is a high-level picture of Amundsen. From the top right, you can see it's called front-end service. And then there are metadata service, search service. Yes, this is a microservice architecture here. So we divided services per domain. UI is one domain by front end. And metadata is another domain. And search is like the last domain over here. Those service, metadata service, and search service is backed by its persistent layer, Neo4j graph database, and search service is backed by Elasticsearch, which is specialized on search itself. And the bottom, there's a Databuilder. It's a crawler. It's an ingestion framework that we use. So let me talk about metadata first. So it's in the left middle in the picture. So remember the page that we show you about the table detail page. So this is rendered by front-end service, but powered by the metadata service. And all the data it has in here, the metadata here, is actually stored in Neo4j, which is a graph database. Graph database is not common use case for many engineers and many applications, and the natural question comes why we chose graph database. So if you recall almost the first slide that Philip mentioned, how the Lyft data architecture looks like, starting from mobile phone, go to Kafka, and then go to S3. Other company can push the data into Hadoop, HDFS. It's very similar. It's not only Lyft are doing that, it's very similar to other org or other company. So let's say you have an application A fires event B consumed by streaming ingestion, C writes the data into Hive table D. And there's a ETL from Airflow DAG E, reads from Hive table, one Hive table, and writes to another Hive table. And that Hive table F has 5 columns read by user L. So the one that I just mentioned is English, and using graph database, you can just draw it. So we think this is very powerful feature of graph database. Once you can speak out your problem, you can just draw it. So that's what we wanted, and that's why we use it. That's one of the problem that one of the things that we think that graph was very attractive. And also, you can see that there's a lot of joining happening in here. There's other database technology like a relational database, that's old one, and NoSQL database. If you want to do joining operation over there, NoSQL database probably out of luck. And relational database, if you come up with like 2-3 joins, you will be hitting the scalability limit. Graph database is born to be doing joining, and it is really powerful on join operation. For reference, this is basically powering the table detail page. You can see there's a lot of nodes and relations, edges associated with it. It's almost, we first started with a skeleton of table, columns, and description. And one powerful thing about graph is once you have new use case, you just add more node and connect the edge between the nodes. So metadata service is basically, is abstract out the problem we want to solve on the metadata space, and we highly leverage Neo4j as a backend persistent layer. Lyft mainly uses Neo4j, but we started working with our partner, ING Bank, and they became our collaborator in open source, and they recently integrated Apache LS. The use case for them is they already invested a lot on adding metadata into Apache LS so that they can just integrate Apache LS into Amundsen. Aside from that, we also have some REST API support for other services to push metadata directly. One other challenge that we had was like, as if you recall from the demo, user can edit a table description or a column description over there. There was a question about like how, if they change the description of the table or the column, should we propagate back to the source? In our case, it's a Hive meta store. So initially we did that. We propagate the metadata update back to the Hive meta store, but it didn't work well. Currently, we stopped that support. For one, there are a couple of reasons. For one even if you push the metadata into Hive Metastore, we found out that the actual golden source was GitHub. And to update GitHub, you need a pull request and get approval from the owner, which is impossible, almost impossible doing that programmatically. And the other one was like portion of our Hive table is a rebuild table. That means that even if we push the metadata update into Hive Metastore, they're gonna use GitHub anyway to rebuild the table, which override the update that we made from Neo4j. So we made a decision to disconnect this link and using our metadata, Amundsen metadata as a golden source. So let's talk about Databuilder. It's about how we are building this graph. There's a lot of challenge on building metadata graph. Databuilder is in the bottom here. The main challenge here is there's so many different metadata source that's coming from, and it's very hard to like make it flexible and extensible to make this happen. So there's no standard schema for fetching metadata, and every metadata source are using different technologies so that it makes harder, even harder. So for example, Hive table is stored in the Hive Metastore, which is backed by a MySQL database. And there's a use case for us that some information is stored in GitHub, and like the one in mode dashboard is actually, you can only get the metadata from REST API. So you can see that there's a lot of use case, variety of metadata sources, and it comes with a challenge. So that's why we built our own ingestion framework called Databuilder. This is highly motivated by Apache Goblin. I'm not sure whether you guys are familiar with Apache Goblin. This diagram here is very similar to Apache Goblin. So you can think this data builder ingestion framework as a ETL engine. ETL stands for extraction, transformation, and load, which fits to our Amundsen use case. Extract from one metadata source, transform to your need, and then load into Neo4j. One particular thing about this data builder is each part, extractor, transformer, loader are modularized so that once you build it, you can mix and match like a Lego block. There's another piece called publisher. This is to support atomicity. Okay, this is one example how we build Hive table metadata on the Hive. On the top left, you can see the Hive icon. Down there, there's called Hive table metadata extractor. If you go down, there's a SQL Alchemy extractor. I'm not sure how many of you guys familiar with SQL Alchemy. It's basically a Python library that supports multiple relational database. And as I mentioned earlier, Hive Metastore is backed by MySQL. So Hive table metadata extractor is basically using SQL Alchemy, and we embedded the SQL statement to get the metadata out from it. So once we extract the metadata from Hive Metastore, we don't need any transformation, so there's no up transformer. And then it passed to, we call file system Neo4j CSV loader. Basically, this one pushes node and edge information into file system in CSV format. And once the CSV file is completed, it goes to the publisher. We call it Neo4j CSV publisher. It reads the CSV file and then publishes it to Neo4j. The reason that we separated loader from publisher is once the loader is finished, you can basically use Neo4j's transaction to make it atomic. This is one example how we define this data builder job in Airflow. The leftmost thing is the one that I just mentioned, how we build a table metadata. Once we have that, you have a basic structure of the graph. Other task is basically decorating the graph. And the last one on the right side is actually publishing to Elasticsearch using the completed graph. Next one is search service. Amundsen is main purpose is for discovery of the metadata. Once we finish building the graph, it's a search service responsibility to make it discoverable. Search service is basically utilizing Elasticsearch, which is famous for searching. And we support multiple different search patterns. A normal search is just search with the term. And category search is basically you can provide more detail, like I want to find something inside the table, inside the column, or a certain tag, or certain schema. And we also support wildcard search. One of the challenge we had was how to make the search result more relevant. I think Philip already mentioned that there's a balance that we need to make between relevancy and popularity. That's being done by adding a function, scoring function to Elasticsearch. Other thing that we worked on was we want to basically confirm whether we are doing the right thing. So for that, Amundsen is actually storing all the user behavior using our product so that we were able to trace our click-through rate. So basically, whatever click they did on our search result, we made sure that it's on the top 5 result. Last one is front-end service. Basically, it's stitching all two services together to render the website. This one is rendered by front-end, powered by search service. And the table detail page is powered by metadata service and rendered by front-end service. Okay, what's next? So we launched Amundsen last September, I believe, and it has been tremendous success in Lyft. We thought that it's going to be useful, but it exceeded our expectation. It's used by data scientists as we expected, but it's also used by engineers, product managers, operations. It's hard to believe, but even used by customer service. We have a 90% penetration rate among the data scientists, which we believe is quite high, higher than we thought. And it gives a boost of 30% productivity for data science organization. I think I already mentioned Amundsen is open sourced. We believe many org have similar problems. There's a link to our code. And we already started collaboration with outside companies. ING Bank, I just mentioned, they already published Amundsen into their production. And we are currently working with WeWork, Square, Bang & Olufsen, and more companies. Here's the roadmap. The theme of this roadmap is completing the graph. The first part is basic metadata. We put table metadata, statistics, usage, and so on. The next phase 2 is bringing more metadata into the graph, adding dashboard, adding people to the graph, and even more metadata, like building a trust from user, like bringing data quality, data SLA, workflow status, even bringing privacy into our graph. We are working on bringing privacy into Amundsen to satisfy CCPA and GDPR requirement. Phase 3 is, again, adding more data into graph, streams, schemas, workflows. And we also want to utilize our graph into our other use case. For example, for superset, we are thinking about adding query helper to the superset. What this means is, like, while users are typing their query, SQL query, Amundsen already knows that which table is being joined by this table a lot, which where clause is being used by this table a lot. We can auto-complete them. Last but not least, we also going to implement governance. Basically, once user discover the data resource, they can ask for the access from Amundsen. In summary, we believe a metadata-powered discovery tool like Amundsen is the key to the next wave of big data applications. We put the blog post. We have a blog post in here, and please join the community. We have a open source code, and also there's a link to the Slack. We have almost real-time support on the Slack channel. So please join, and let's make Amundsen better.